Hi, hello friends, welcome back to Max lecture series. In this lecture series, we will be learning all fundamental basics of vector quantities. So let us learn a few more things here. If you observe the given function, the given question is f of x comma y comma z function is defined as x, y, z. Now the question is, if you observe, what is the question? The question is curl of gradient of f equal to dash. Now I am asking whether the given function f is a scalar quantity or it is a vector quantity. You have to say, your common sense has to work here. Sir, we already saw that gradient will always be deals with the scalar functions. Gradient of f, gradient of function means always what? Your function should be scalar, then only this word gradient will come. Otherwise the divergence will play. If your function is a vector function, then we should call divergence of f. If they are calling the function is gradient of f, means your function should be a scalar function. Then only that word gradient should appear. Okay sir. Now let us see how to express the answer for curl of gradient of f. First what we will be going to do is, we will be trying to catch up only gradient of f. After that we will be calculating curl of f. Let us see. Gradient of f, we know how to represent the gradient, dou by dou x into I vector, dou by dou y into j vector, dou by dou z into k vector. Dot function f can be simply represented as x, y, z. After that, if you simply observe here, if we differentiate this function first with respect to, see, I am just opening the brackets and this x, y, z will going to be a common term for all these expressions. After, we can write like this, dou by dou x into x, y, z, dou by dou y into x, y, z, dou by dou z into x, y, z. Now if you differentiate the first one with respect to x, we will be getting y z into I vector. Yes, if you observe here, because we are differentiating with respect to x, so here x will become 1, second case y will become 1, third case z will become 1. So the final expression for this gradient of f can be written as y z into I vector, x z into j vector, x y into k vector. Now it's time to calculate the curl of this whole function. I am putting some name for this, that is p, simply to understand. Now tell me, how will you write down the curl of a vector field? How will you express the curl of a vector field? In the first row we have to write ijk, in the second row we have to write down the differential operator, dou by dou x, dou by dou y, dou by dou z. After that, in the third row we should collect the coefficient of a given vector field. See there, vector field. Here we are trying to substitute, here our vector field is p, or gradient of f. Coefficient of I vector is yz, coefficient of j vector is xz, coefficient of k vector is xy. So we have substituted yz, xz, xy. Now what we have to do? Calculate the determinant. See, here we have to estimate the determinant of the overall function. Let us see, I vector in bracket, what we have to do? Dou by dou y dot xy minus dou by dou z dot xz. First one is over. Yes sir. Similarly, let us express the second one, plus, not plus, it should be minus j vector. I hope you all know, I am assuming that you all know how to calculate determinant of the function. So j vector, it can be written as dou by dou x dot xy minus dou by dou z dot yz, then plus k vector. K vector can be expressed, how will you express it? Dou by dou x dot xz minus dou by dou y dot yz. What will be the resultant answer? Let us see. If you take I vector, first one, if we differentiate with respect to dou by dou y with respect to y, this will become xy with respect to y will become x minus xz with respect to z, it will become x. X minus x will become 0. Minus j vector, see there, xy with respect to x will become y minus yz with respect to z will become y. This is also become 0. Then k vector, last one, xz with respect to x will become z, yz with respect to y also will become z. Sir, what is the conclusion? The overall value of the function is going to be 0. So what is the conclusion? Actually, we were trying to calculate the value of curl means del cross del dot f. So here curl, this will be the indication of curl. Of course, this operator depends on the function. If you are choosing a scalar function here, then this will be differentiated. This will be called gradient. This whole will be treated as gradient. So what is the conclusion? curl of gradient of a function is always equal to 0. It doesn't matter what type of scalar function that you are choosing, curl of gradient of a function is always equal to 0. That is the conclusion. Don't forget this, that is very very important. Hereafter in the examination, while solving any problem, don't forget, don't think about the kind of the scalar function. It can be any type of scalar function. Your one and only work is, if you are requested to calculate the curl of gradient of a function, just blindly put your answer is 0. That's all. This is the basic observation from the derivation. See, just we did, I have been proved this, I didn't told anything blindly. So this is the proof, this is the observation. So it is always 0 irrespective of the scalar function. This is all for this lecture. In the next lecture we will be coming up with one more question. Thank you all.